Continuing on in section 5.3, here I'm going to switch from mixed numbers to improper fractions. Take denominator times whole number plus numerator. Here that gives me 67 over 10 plus negative 5 times 1, 5 plus 1, 6. 6 over 5. Now that I have improper fractions, I can go ahead and get common denominators. So between 10 and 5, my least common denominator is the least common multiple of my denominators, which is 10, the smallest number that they can both multiply to. Now, 10 on my left side is already my denominator, so I keep my numerator. On my right side, I have to multiply 5 by 2 to get to 10, so I have to multiply the top as well. If I change the denominator, I have to change the numerator. Now, I have a common denominator, so I can keep that denominator, perform the operations on my numerator. So 67 plus negative 12. Different signs, we go ahead and subtract, give the sign of the bigger number. So here I'm going to get 55 over 10. Keep that denominator. 55 is bigger, so we can go ahead and divide. Numerator divided by denominator. 10 goes into 55 5 times. Multiply back is 50. Subtract and we get 5 as our remainder. So I'm going to have 5 and 5 over 10. We keep that denominator. Last thing we want to do is reduce if we can. Between 5 and 10, I can take a 5 out of each of them. So 5 divided by 5 is 1. 10 divided by 5 is 2. So here I get 5 and 1/2. In 3, again, here I have mixed numbers. So I'm going to switch from my mixed numbers to improper fractions by taking denominator times whole number plus numerator. 3 times 2 is 6 plus 1 is 7. I keep my denominator and I keep my sign. Here I take 5 times 6, denominator times whole number, then I add that numerator. So I get 33. 3 and 5 are not common denominators, so I need to find the least common multiple of them. The smallest number that both 3 and 5 go into, since they're relatively prime, is their product, 15. So I'm going to rewrite my fractions as equivalent fractions with a common denominator of 15. To go from 3 to 15, I have to multiply by 5, and if I change my denominator, I have to change my numerator. So I have negative 35 over 15. Here, to go from 5 to 15, I have to multiply by 3. If I change my denominator, I have to change my numerator. So I have 99 over 15. Now that I have a common denominator, I keep my denominator and perform my operations on my numerator. Negative 33 plus 99. They have different signs, so I go ahead and subtract 64. Give the sign of the bigger number, which is 99, so positive. 64 is bigger than 15, so I go ahead and divide. Numerator divided by denominator. 15 goes into 64 4 times, which when I multiply back is 60, and I subtract. 4 is my remainder. So as far as my answer goes, what I got when I divided is my whole number. My remainder is my numerator, and my denominator is my original common denominator. We check here to see if that reduces, but 4 and 15 are relatively prime, so we keep it as 4 and 4/15. In example 3, we're going to subtract mixed numbers. So my first step when I have subtraction is to change it to adding the opposite. So what I have here is 10 and 1/5 plus negative 5 and 3/4. So instead of subtracting a positive number, I add a negative number. We change from subtraction to adding the opposite. And now I do it just like we did for the last few. Denominator times whole number plus numerator. 51, and I keep that over 5. Plus negative 5 times 4 plus 3. 23 over 4. 5 and 4 are not common. Okay, they're not the same, and they don't have any common factors. They're other than 1. They're relatively prime, which means we multiply them together to get our least common multiple, which becomes our least common denominator. To go from 5 to 20, I have to multiply by 4. If I change my denominator, I also have to change my numerator. So here I get 204. To go from 4 to 20, I have to multiply by 5. If I change my denominator, I also have to change my numerator. So here, I end up with 115. Now that I have that common denominator, I can rewrite it with my common denominator and perform the operations on my numerators. So 204 plus negative 115. Different signs, so we go ahead and subtract. Give the sign of the bigger number, so here it's positive. 89 is bigger than 20, so we go ahead and divide. Numerator divided by denominator. 20 goes into 80. Think about 2 into 8 4 times. When I multiply it back, I get 80. Subtract remainder of 9. So my answer then, whole number, remainder becomes my numerator. Denominator stays 20 here. And 9 and 20 are relatively prime. I cannot reduce there. Again, here I have subtraction, so I'm going to change to adding the opposite. So I have 5 and 4/11 plus negative 2 and 2/3. I don't have common denominators, but I can get some. First, I'm going to switch to improper fractions. 11 times 5 is 55 plus 4, 59 over 11, plus negative 3 times 2, 6 plus 2, 8 over 3. 11 and 3 are relatively prime, which means I multiply them together to get my common denominator. I have to take 11 times 3 to get to 33, which means I multiply my numerator as well. And here I end up with 177. Plus negative. To go from 3 to 33, I have to multiply by 11, so I have to multiply my numerator as well. If I change one part of my fraction, I have to change the entire fraction. Now that I have a common denominator, I can rewrite it over that common denominator and perform the operation with my numerators. Different signs, so we go ahead and subtract, give the sign of the bigger number, and since 89 is bigger here, we can divide. Numerator divided by denominator. 33 goes into 89 twice, which when I multiply back is 66. We subtract and get 23 as our remainder. So here I get 2 and 23 over 33, and that does not simplify. Number 5, again, I'm going to change from subtraction to adding the opposite. So I have negative 1 and 3/7 plus negative 2 and 3/14. 7 times 1 plus 3 gives me negative 10 over 7 as an improper fraction, plus negative 14 times 2 plus 3, 31 over 14. I look at my denominators between 7 and 14. My least common multiple is going to be 14. It's the smallest number they both multiply to. 7 times 2 is how I get to 14. So I have to multiply my numerator as well, which gives me negative 20. 14 already is the same, so I keep it as 31. Here, we have a common denominator, so I can keep that denominator, perform the operations on my numerators. And I have the same sign, so we go ahead and add those up, give that common sign. 51 is bigger than 14, so we go ahead and divide. 14 goes into 51 3 times, which when I multiply back is 42. When we subtract, we get a remainder of 9. Don't forget here that our answer is negative. So I get negative whole number, remainder is my numerator, over denominator is what I divided by. In 6, I have subtraction, so I'm going to change to adding the opposite. So I actually have 4 and 3/8 plus 1 2/3. I'm going to switch to improper fractions. 8 times 4 plus 3, 35 over 8. 3 times 1 plus 2, 5 over 3. Now, 8 and 3 are relatively prime, which means I can multiply them together to get my common denominator of 24. To go from 8 to 24, I have to multiply by 3, and if I change my denominator, I have to change my numerator. To go from 3 to 24, I have to multiply by 8, and if I change my denominator, I have to change my numerator. Now, I have a common denominator of 24, so I write it as one fraction and perform the operations on my numerator. Same sign, so I add them up. Now I can divide because my numerator is bigger. 145 divided by 24. So it's going to give me a 5. Actually, it's going to give me a 6. Sorry. 24, 144. Remainder 1. So here, whole number 6. Remainder is my numerator. Denominator is 24. And I get 6 and 1/24. In example 4, we're going to simplify an expression with variables, but it's going to work a lot of the same way. I have subtraction, so I change to adding the opposite. I don't have to switch to mixed numbers here because I don't have, I don't have to switch from mixed numbers to improper fractions because I don't have mixed numbers. So I look at my denominators between 2 and 6. My least common denominator is 6. So I'm going to rewrite my fractions with that common denominator. To go from 2 to 6, I have to multiply by 3. And if I multiply my denominator by 3, I also have to multiply my numerator. So a times 3 is the same as 3a. 6 is already 6. So remember our coefficient, there's a 1 if there isn't one written. So I have negative 1a. Now that my denominators are the same, I can rewrite it with that common denominator of 6 and perform the operations on my numerators. Since they're both a terms here, they're like terms and I can combine them. So 3 minus 1 gives me 2a, and that's still over 6. And then we always want to reduce if we can. So I can take a 2 out of each of these, which gives me just 1a over 3. We don't need the 1 there. If you want to just put a over 3, you sure can. And that's all I have for section 5.3.